Hello learners, welcome to grade 12, Physical Science Paper 1, Chapter 1, Newton's Laws of Motion, Lesson number 3. Frictional force. This is the formula for calculating the frictional force acting on an object. F is equal to mu times normal force, N, where mu is the coefficient of friction, pronounced as mu. There are two types of frictional forces, namely kinetic frictional force and static frictional force. The coefficient of static frictional force acting on an object is always greater than the coefficient of kinetic friction. Therefore, kinetic friction is always less than the maximum static friction. Below the maximum static frictional force, the static frictional force is always equal to the applied force and the object doesn't move. Therefore, the static friction acting on an object is not constant. It depends on the applied force acting on the object. The object will move only if the applied force is greater than the maximum static frictional force of the object. When the object starts moving, the magnitude of the frictional force acting on it decreases and remains constant throughout the motion, and this frictional force is known as the kinetic friction. Kinetic friction is always constant, it does not change. As you can see from the graph below, it is a graph of frictional force against the applied force acting on an object. The frictional force is directly proportional to the applied force below the maximum static frictional force. And this type of a frictional force is known as the static frictional force. Above the maximum static frictional force, which means the applied force is greater than the maximum static frictional force, the frictional force acting on the object drops down and remains constant throughout the motion. This type of a friction is known as the kinetic friction. Tension in ropes. Tension is a pulling force acting in ropes. Tensional force always tends to pull an object the rope is connected to. If the rope is connected to two objects, the tensional force pulls from both sides, the same magnitude. Tensional force can never tend to push an object. That is an object which is being pulled vertically by a tension, and this one is being pulled horizontally to the right by a tension. Given two objects connected together by a light inextensible string, and if the object B is pulled by a tension or by an applied force, the tension acting on A, it pulls it to the right, and the tension acting on B, it pulls it to the left. And of course we have the applied force.